Thank you for joining this Quantum Security Defense webinar, Quantum Safe Networking and the Future of Quantum Security. Zhou is the CEO and co-founder of Gopher Security, where he leads the development of the world's first quantum-resistant MCP server and gateway platform, securing agentic AI workflows with deep inspection, context-aware access control, and post-quantum end-to-end encryption, powered by Gopher Quantum Safe Networking Systems. A serial entrepreneur and builder at heart, Edward has over 2 decades of experience spanning distributed systems, enterprise infrastructure, and cybersecurity. He previously built a consumer cybersecurity product that reached over 2 million users and served as a senior Hadoop engineer at Hortonworks. Edward holds a master's degree in big data and distributed systems from the Illinois Institute of Technology and is based in the San Francisco Bay Area. Alan Gutnov is the co-founder and director of strategy at Gopher Security, where he drives the GTM for quantum-resistant cybersecurity solutions built. Alan specializes in translating complex security architectures into actionable business value for enterprise customers, CISOs, and IT leaders. Prior to Gopher Security, Alan worked in energy consulting at OOE, focusing on deep technical consulting and stakeholder management. He holds an MBA from DePaul Kellstadt Graduate School of Business and combines technical fluency in post-quantum cryptography, zero-trust architecture, and MCP security with strategic GTM expertise. At Gopher, Alan works directly with organizations preparing for quantum migration, helping them understand the business implications of NIST's post-quantum standards and quantum-safe networking strategies.
Thank you so much for having us. We're very excited to present today. So what we'll be discussing is quantum safe networking. So what Gopher Security delivers and what we prevent. And first of all, why the name Gopher, right? So Gophers, they're excellent tunnel diggers. So if you ever have this question at trivia night, they dig 18 feet of tunnels per hour. So that's where the metaphor comes from. We're also digging tunnels. We're allowing you to connect your machines, devices, users, everything in between with quantum encrypted tunnels. So providing you SDR, software-defined perimeters, and giving you safe infrastructure, whether you're connecting your AI models, your entire network, connecting all your machines, users, and devices. So our first slide here, what I'll address is the critical security gaps that we identified. So, we're looking at the current infrastructure where quantum attacks would be the first prevalent points. Critical infrastructure that needs to be secure because obviously quantum computers are evolving a lot quicker than anticipated. We're seeing massive leaps in technology. And so the first attack vector is quantum deployment will make standard encryption models obsolete within 3 to 5 years. So this is addressing energy sectors, finance, government. Those are probably the key targets for quantum attacks once quantum computers have practical deployment. Second is no micro-segmentation. So without micro-segmentation, when a breach occurs, hackers are able to move around laterally. Very often they go undetected. And this, basically, when you have an attacker moving laterally from one compromised system, basically it compromises the entire agency database. Thirdly, we have a legacy network architecture. So traditional perimeters create single points of failure, especially when you're using VPNs. So one breach can compromise the entire network. And then also for remote forces. So nowadays everyone's working remotely, like us, for example, we're all joining from all over the world. So as much utilities we gain from being able to connect worldwide, this also presents a lot of attack surfaces. And so with this remote connectivity, there's a massive threat for hackers to exploit, especially with your engineering teams, your development teams, all connecting to critical infrastructure, which also needs to be quantum safe. Thirdly, unpatched legacy systems. So software updates, everyone that needs to transition to post-quantum cryptography. So all of this, there's a lot of work ahead of us in order to make sure that entire infrastructures are all moving to quantum safe practices in an organized and standardized fashion. And finally, no zero trust model. So lack of zero trust allows attackers to move laterally, like I mentioned. undetected across your entire infrastructure. And with quantum computers, that threat becomes a lot more realistic and a lot harder to manage.
Thank you for watching this preview. The entire presentation and over 150 quantum and advanced AI presentations from industry leaders are available on QSECDEF. Search for Quantum Security Defense to find out more.